From the outside, this building near Hamburg provides little indication that one of the most exciting projects currently underway at Airbus is taking place here. It's 3D printing, otherwise known as additive layer manufacturing. These remarkable printers are able to produce metal printed parts for the whole range of Airbus aircraft that are lighter, stronger, and potentially substantially cheaper to make than at the moment. Peter Sander from the Emerging Technologies and Concepts Department is overseeing a part of this amazing innovation transformation, and he can barely contain his excitement.
Well, I have 32 years experience in Airbus, and I did 10 different jobs. But this one, I tell you, in my point of view, is the most amazing story which comes up. This will change our world.
How does it work? 3D printing consists of producing a three-dimensional object from a digital file, like this one of a metal bracket that fits on an aircraft, while a 2D printer, like any standard photocopier, reproduces a text or image on paper by laying down a toner on the surface. 3D printing adds a vital new layer, height. Instead of ink toner, the 3D printers here use powder from different metals, including titanium, steel, and plastics. On the brand new A350 XWB are plastic covers that protect electric wires. Several hundred of these parts fit onto the A350, and thanks to 3D printing, it took 70% less time to make them, and the manufacturing cost plunges 80%.
We're at, I would say, the beginning of the start of the revolution for 3D printing in the aircraft industry. We're now being able to discover exactly where we can apply it, how we can apply it, and understanding the scope of the benefit it can bring to the aircraft as a whole.
Costs aside, there are huge advantages with 3D printing. There's up to 95% less metal waste, which is great for the environment as all the metal needed to make parts is used, unlike with traditional milling. The turnaround time to make parts can be as little as 24 hours, slashing needs for large stocks, which means far more agile factories and far more elaborate parts can be developed.
Well, this is a very interesting part because normally this is a part of a fuel system. It's 2 pipes in one, and it's normally welded out of 10 parts. So in this case, with 3D printing, we had the chance to integrate the bracket of the pipe and 2 pipes in one and print it in one shot. So in this case, we have weight reduction, but of course, the most interesting thing is that we have a cost reduction down to 30%.
Another great advantage is retrofitting. One airline with an A310 in service is already flying with a 3D printed part. It's this plastic safety belt holder. The supplier is no longer in business. The molds were lost and rebuilding them would have cost thousands of dollars and been time consuming. Instead, Airbus designed a new holder and simply 3D printed it.
Well, of course, this is a plastic part. It's part of a seat, and it's a spare part. We did a project together with our spare part colleagues. And this is a 30-year-old design, and the supplier is no longer available. The tools have been scrapped, and we have a need of something about 100 parts a year. So they have to decide to invest in new tools or to use 3D printing technology as an enabler to do it without any tooling and something like this. So we did a redesign in a week and printing in a week. So the redesign itself cost 2 hours. We took the manual drawing, redesigned it, and they printed it and put it on the desk 1 week later to the spare part guys.
For airlines, the advantages are substantial. Finding spare parts quickly, just a printer away, and of course lighter, stronger parts on board means massive weight savings and lower fuel bills. In the long term, 3D printing could reduce weight on each aircraft by more than a ton.
For the airlines, the biggest benefit, I would say today, is the weight we reduce from the aircraft. With reducing the weight, we're not only saving costs on our side, but we're also introducing a way for them to improve their fuel burn, save money on their fuel, improve their revenue, and operate the aircraft more efficiently.
The first commercial flights with metal 3D parts are expected by 2016 and mass production by 2018, with 30 tons of metallic parts printed every month.